Hello, welcome to lecture 15. This is the final chapter of your book. This is the appendix. This is mathematics for class 9 based on NCERT syllabus. My name is Sangam Banerjee and my details are given below. So I will discuss here the appendix chapter of your book. It's a final chapter of your book. It gives some mathematical statements. For the sake of completeness, I will discuss this also. I thought that I have missed this, so I should tell this portion also. So here, mathematically acceptable statement. In mathematics, a statement is only acceptable or valid if it is either true or false. Like example, a product of two odd integers is always odd is a true statement. A product of two odd integers is always even is a false statement. Then there is something called deductive reasoning. The process of concluding that something must be true because it is a special case of a general principle that is known to be true. So if example, if A is equal to B and if B is equal to C, which is known to be true generally, then A is equal to C. So this is by deduction. So you deduce that from these two statements, then A is equal to C also. Then there is something called theorems, conjectures and axioms, which we have defined earlier also. So for completeness sake, let us repeat again. A mathematical statement which has a proof is a theorem that we have in our previous lecture also. We have discussed this in great detail. A conjecture is a mathematical statement when one notices a pattern that holds true for many cases but has not yet been rigorously proved. And if conjecture is proved, then it becomes a theorem. Okay. So when a conjecture is rigorously proved, it becomes a theorem. If a statement is always true and doesn't need proof, it is an axiom. That also we have discussed in detail in our earlier classes. Then division by zero is not defined. Okay. So this we will prove by contradiction. We will say what contradiction, proof by contradiction is in the next slide. So how do we prove division by 0 is not defined? So if any number x is not equal to 0, division by 0, say if it is possible, then x by 0 is some other number, say y, some other real number. Then x divided by 0 is equal to y, because you are saying that division is possible by 0 and x is a non-zero. So it is y, which may be some real number. So I can write x is equal to y into 0. Okay, here x is equal to 0 into y. So but any number multiplied by 0, we know it is 0, which we have discussed earlier. So x is equal to 0, but we have assumed that x is not equal to 0, but you are getting a contrary that x is equal to 0. So our prior assumption was wrong. So here I ask you a question, what is 0 divided by 0? Okay, so that you have to think, but here the simple explanation says 0 by 0, say again if it is divisible, 0 by 0 is say some real number k, but here k can be anything then. Okay, so k can be anything. So this is indeterminate. Okay, just think about it. So now proof by contradiction. We saw in our previous example, we prove that x divided by 0 is not defined because we assumed that okay, let x divided by 0 is possible. So I call x divided by 0 as k for non-zero x, but then I found that x has to be 0. So it is a negation of our assumption. So our what the statement is then may be true. So to prove a statement P by contradiction, you assume the negation of what you want to prove and try to derive a contradiction. Since a contradiction is always false, your assumption must be false. So the original statement P must be true. So original what I have said that any number divided by 0 is not defined is true. Now we come to useless axioms. There are few axioms. One of them says things which are equal to the same things are equal to one another. Means A is equal to C and B is also equal to C. The same thing, both are equal to the same thing C. Then A equal to B. Okay, hence A, B, C are the same kind of things. Then if equals are added to equals, the whole are equal. Suppose A equal to B and C equal to D. So these equals when you add, say A plus C is equal to B plus D. Okay, so this is whole A plus C and B. So if equals, if you add, the wholes are also equal. And also a plus c is equal to b plus d, or a plus d is equal to b plus d, okay, because these are all equal. Because d is equal to c, here it is, and c is equal to d. Then if equals are subtracted from equals, the remainders are equals. So suppose this equals a equal to b and c equal to, these are two equals. Now if I subtract a minus c and b minus d, then a minus c is equal to b minus c, and also a minus c is equal to b minus d, like the earlier one. Things which coincide with one another are equal to one another. That is congruency. Example, congruency. The whole is greater than the part. So what it means, the part is a portion which you have taken off. So definitely the whole will be greater than that portion which is been taken out. So if a is greater than b, then there exists c such that a is equal to, because a is greater than b, so you can have some c here, something you can add so that you can make it. So a equal to b plus c, here b is a part of a, so a is greater than b. Things which are double of the same things are equal to another. If you double it, if suppose you have two things, you double it, both again will be same. And similarly, if you make it into half, so suppose if you have a chocolate, two chocolate, and you divide into half, the two half will be equal to one another. Okay. Now we'll mention few useless postulates. Postulates are also quite similar to axioms, but axioms are too obvious, but postulates are not so obvious. So you is like like an idea which you propose. So a straight line segment can be drawn joining any 2 points. So if you have 2 points A and B, I can always draw a straight line between them. Of course you can draw many lines, but they are not, others are not straight line, they are all curved line. Second, any straight line segment can be extended indefinitely in a straight line. So if you have a straight line, you can extend it indefinitely in a straight line. Okay. Then given any straight line segment, if you have a segment AB, then a circle can be drawn having the segment as a radius and one endpoint as a center. So if you have a segment AB, I keep A fixed and I can just revolve around a center called A. So that A, the endpoint A is now a center. So if I revolve around A, keeping AB fixed, you get a circle. All right angles are congruent. So right angle means 90 degrees. So all right angle, all are 90 degrees. They are all congruent, same angle. Now if two lines are drawn, suppose you draw two lines parallel. If it is parallel, they will not intersect. But if it is not parallel, then they will intersect, which we have discussed in our previous, that if it is less than 180 degree, the complementary angle, if there is a traversal, then it will intersect where the complementary angle is less than 180 degree. And the other side, the complementary angle becomes more than 180, the lines diverges. So this is what it is saying here. If two lines are drawn which intersects a third in such a way that the sum of the inner angles of one side is less than two right angle, that is two right angle means 90 plus 90, 180 degree, then the two lines inevitably must intersect each other on that side if extended far enough. So because it's converging, so you keep on extending, it will intersect on that side, okay, where your angles are less than two right angle, that is angle is less than 180 degree. This postulate is equivalent to what is known as the parallel postulate. What is a mathematical proof? A proof is logical argument that tries to show that a statement is true. That we have been doing all along, okay. So let us see one more example from your book only. We will try to prove this. The product of any three consecutive even natural number is divisible by 16. Even number means which you can divide by 2, and odd is the numbers which you cannot divide by 2. Okay, to get a natural number, you will get some fraction. So how do you go about proving it? Mathematical proof. So proof is, suppose even number means it is 2 times any number is an even number, because you can divide by 2 and get n. So every alternate numbers are even number, so 2n, then you have to jump 1, and the second number 2n plus 2 is again an even number, 2n plus 4 is also, and these are all divisible by 2, so they are even. Okay, so now is asking that product means if you multiply 2n into 2n plus 1 into 2n plus 4, if I write like this, I keep 2n here, 2 I bring it common, n plus 1, and again 2 I bring it here, n plus 2. So I have 2 into 2 into 2, and this n is here. I can write like this, n plus 1 into n. So I get 2 into 2 into 2 is 2 to the 4 to the 8, 8n, like this. So I can simplify this as this, and then n is either even or odd, because if suppose 5 is an odd number, 2 into 5 is 10, it is an even number, okay, or 9 is an odd number, 2 into 9, 18, it is an even number, even though n is a odd. So any number, n can be anything, odd or even, when you multiply 2, it becomes even, okay. So either n is even or odd for this, and if n is even, then n equal to say 2m, okay. This m also again now belongs to natural number n, capital N here, okay. M, this is a sign belongs to n. Sometime I may not mention all this notation, but please go to internet and see what this notation means. So, and then I can write this equal to this, and this n is an even number. If n is even number, this is 2m, so it is 16. So this number is divisible by 16. So similarly, if n is odd, then n plus 1 is even, and we can write n plus 1 is equal to twice r, because it's even. Any number if you multiply by 2 becomes even, as I said, whether it is odd or even. So it is r belongs to n. So I can write again the same thing here, and here I can write this n, 8n, n is 2r minus 1, I substitute here. Then this n plus 1 is equal to 2r, I write here 2r, and this n plus 2 is 2r plus 1, I write here. So again I will get here 16r, this. So here is a 16, this factor 16 is there, so I can divide by 16. So again, therefore, this is also divisible by 16, even if n is odd. So in both cases, we have proved that product of any 3 consecutive even number is divisible by 16. So this is a proof, okay. So in mathematics, you have to prove like this. So let us, this is the appendix, this is the main point of the appendix 1, and mostly we have already discussed this in this current lecture. So in this appendix, we have studied the following point. In mathematics, statement is only acceptable if it is either always true or always false. To show the mathematical statement is false, it is enough to find a single counter that is proved by contradiction. Axioms are statements which are assumed to be true without proof, as I mentioned earlier. Postulates are very similar to axiom, but that is, you are just postulating it, that is, you are just proposing it, but it is not so obvious, okay. And a conjecture is a statement we believe is true based on mathematical intuition, and but which is yet to be proved. So conjecture means, okay, if suppose few things are true, maybe this is also true. So these are very subtle. Axiom, postulates, and conjectures, they are very subtly used. So when you do mathematics, many examples, then you will know what conjecture is. Like Srinivasa Ramanujan had put lot of conjectures, people are trying to prove it, and once they prove it, it becomes a theorem. I believe you know who Srinivasa Ramanujan is. He was one of the greatest Indian mathematician. So please go through internet and try to learn about him and know about him. So a mathematical statement whose truth has been established or proved is called a theorem. The main logical tool in proving mathematical statement is deductive reasoning. This is the main, by you have to logically derive things. A proof is made up of successive sequence of mathematical statements, okay. Each statement in a proof is logically deduced from a previously known statement or from a theorem proved earlier, or an axiom, or the hypothesis, okay. So these words you should go to the internet and try to understand exactly what it means, this axiom, conjectures, theorem, but I have told as much as I could. And now we come to mathematical modeling. Mathematical modeling is a process of describing a real world problem, okay. So to describe the real world problem, you have to make a mathematical model. Suppose you want to forecast weather, so you have to make a model with so many parameters, inputs, conditions, and then you write some formula, and they say if these conditions are there, then this can happen. So these are called the modeling. Okay. So mathematical modeling is the process of describing a real world problem in a mathematical terms, usually in the form of equation, and then using this equation both to help us understand the original problem and also to discover new features about the problem. It is used for prediction about the real world, as I said, okay, to forecast, to understand situation, and to assist in making decisions. So you can make decision accordingly. It is a bridge between the real world and the mathematics. The stages involved in mathematical modeling are formulation. So there are 3 steps: formulation, solution, and interpretation. And if you still have some doubt, you go back to the earlier formulation and validate it, start thinking. So this validation generally happens when you deal with statistics. Okay, but mostly if statistics is not there, if it's exact things, then you cannot do this validation. Okay, of course you can substitute this answer and see, but that is not really validation, it's confirmation of your solution. So anyway, let us proceed. Example: suppose a car starts from place A and travels at a speed 40 kilometers per hour towards another point B. So say A is in the left hand side, it moves towards B at 40 kilometers per hour. At the same instant, another car starts from B, which is in the right hand side, and travels towards A, towards left hand side, at a speed of 30 kilometers per hour. This is slower. If the distance between A and B is 100 kilometers, after how much time will the car meet? So definitely this higher speed, it will go longer distance than the B. So here I have drawn here 100 kilometers. So this car is moving at 40 kilometers per hour towards B, and from here it goes at 30 kilometers. So somewhere here it will try to meet. So what is the distance? What is the distance AC and BC? AB is 100 kilometers given. So formulation is your AC, this is the distance, this is the speed, okay, kilometers per hour into time. That will give you the distance, because this hour get cancelled, you are remaining only with the dimension of distance, kilometer. So velocity into time, because velocity is distance covered per unit time, time get cancelled. So this is your AC distance. And BC is equal to 30 kilometers, this is the speed given, okay, per hour into T, that is also in hour. So here AB is 100 and BC is what? BC, the distance is here I have written 30 into time, here I have written. So you can take this minus 30 to the left hand side, becomes plus 30, 40 plus 30 is 70, 70 times T, so T is equal to 100 by 70. So I get time is equal to 100 by 70. This is the solution. So this is the formulation of the problem. Then I get a solution and then I interpret. That is, the car will meet after time 100 by 70. That is 1.428 hours. And what is 1.428? I can again do some, I know 1 hour is 60 minutes, 1 minute is 60 seconds. I convert it. So this is your homework. You have done it in very elementary classes, so I am not going to do it here. So solution is exact and not statistical, so validation is not required. So another example, how do you model it? The moon is about 384,000 kilometers from Earth and its path around the Earth is nearly circular. Find the speed at which it orbits the Earth, assuming that it orbits the Earth in 24 hours. So this is the radius, okay, 384,000. Outside India, they don't use the word lakhs. 100,000 is actually 1 lakh. So it is 300,000. So 384,000. Okay, so this is the radius, and the circumference, the perimeter will be 2 pi times this radius. So he's asking what is the speed. So 2 pi r divided by 24 hours should give me a speed. Okay. So here the speed at which the moon orbits the earth is length of the orbit divided by time taken. So this is 24,11,520 divided by 20. So you get 1,480 kilometers per hour. Okay, 100,000 is 1 lakh, I said. So interpretation is the speed is this much amount kilometers per hour 1,480 kilometers per hour. Now we summarize the appendix. So that is appendix 2. In this appendix you have studied the following points. The steps involved in solving word problem, we have discussed this. What are the steps involved? Construction of some mathematical model. We have seen how to construct a mathematical model, formulation, solution and interpretation. The steps involved in mathematical are given in the box below. That is what I have said: formulation, stating the question, then identifying the relevant factors, mathematical descriptions, and finding the solution. You find the solution. Okay. Then interpretation of the solution. Okay. Then you, in the context of the real world problem, and then checking and validation, to what extent the model is good representation of the problem being studied. So as I said, validations are required in statistical cases. Okay, you can of course do the checking. Then the aim, advantage and limitation of mathematical modeling. What are the limitations? Suppose you do not know all the factors. So like while predicting weather, sometimes we miss some parameters, and when we calculate, we come to wrong solution or wrong answer. Okay, this happens in disease progression. If you want to model how a disease is progressing, but if you don't take all the parameters, then again you can go to wrong conclusion. So this is the end of your chapters. I have something to say. Now we have covered whole class 9 mathematics NCERT syllabus. My advice is, discuss with friends and share this lecture with your friends. Subscribe this channel to get updates. Send your comments, suggestion and doubts to my Gmail account. This is, I have made a special Gmail account for these lectures. And I hope this series of lecture will help you in your understanding. But there is no substitute to practice. You have to practice. Okay, I have given you main, the important things, but you have to, the minor details you have to fill in those gaps. So you have to practice. I would rather advise that after listening to all this lecture, you go see all the examples again. Try to solve exercises by yourself. Don't go around searching for it. Most of the things we have discussed here, and if you keep do searching, you will keep on searching. So you better take your textbooks and try to practice it. Most of it is covered in this lecture. In case you feel that okay, you are not able to, then maybe you should look internet and try to find out the solutions. Write your own notes by pausing and replaying the videos. Write your notes. Okay, as I have written very small, you can still concise it and make it more compact than what in 8-10 slides I have done it. You can still write in one page what I have taught. So it becomes much easy before the exams to do revision. Read the textbook and try to solve the missed examples and exercises. Some of the examples I have skipped, which I felt is too trivial and too easy. So you should try to do those examples and exercises. You can increase the playback speed. I would recommend that you should, after listening once slowly, you can again when you want to listen again, you increase the speed so that you save time. And half an hour lecture can become 20 minutes, or 40 minutes lecture will become less than 30 minutes. So you can increase the speed. I always, when I do like this, I increase the speed in the next, when I want to listen the same lecture again. And all the best for your exams and endeavor. And encourage and motivate me by subscribing and liking the lectures. Then only I will continue. And see you all again in class 10 maths lecture. So I will end here, and all the best to you all for class 9 examination. And thank you, and see you in next 10th class math lecture. I hope you will continue listening to the class 10 maths lecture if you are in 9th standard. Okay, during vacation you can listen to these notes. Thank you.